The last method we're going to discuss for decimal multiplication is estimation and reasoning. I really like this method. I debate on whether this should kind of maybe replace the standard algorithm just because I like it so much. Estimation and reasoning, what you're going to do is before you do your multiplication, you are going to estimate. So what I'll often do is I will take the two things that I'm multiplying and just round them to the nearest whole number. I don't always do that. Sometimes if it's easier, I might go ahead and round it down. Or, I might round it to a decimal if that decimal is nice and easy. Basically, whatever estimate you want to use, you want to make sure you're doing something that you can do easily in your head. So like 85 and 7/10, if I just round that normally, that would be 86, right? If I round it to the nearest whole number. 2 and 36/100, the nearest whole number there would be 2, right? And so is that easy enough that I could do it in my head or with very, very little work, right? I want it to be something that's very easy to do, because if it's difficult, then why wouldn't I just do the actual multiplication, right? So 86 times 2, usually multiplying things by 2 is not bad because you're just doubling, right? So like you could maybe find a mental math way of doing that. For me personally, I'm like, well, if I do 6 times 2, or if I double 6, that's 12, right? If I double 80, that's 160. And so if I add those together, that's 172. But whatever methods you like, you just want it to be something that is easy to compute, right? And so in terms of showing your work for my purposes, for me, make sure that you show me what you used to estimate, and then also show me what you got, right? So I'm estimating. I'm saying, okay, 85 and 7/10 times 2 and 36/100, that's roughly 86 times 2, which is roughly 172. And this might be something, I would do in practice, right? If I was going to go to the store and something's listed for $2.36, I just might say to myself, oh, it's about $2, right? So it's kind of the same idea. Then what I'm going to do is I'm going to do the multiplication, but I'm not even going to put those decimals in there, right? I am literally going to multiply 857 times 236. And guys, I like the standard algorithm, but if you do the lattice method or whatever methods you like, or whatever methods you did from 201, as long as you show your work, right? Then that's fine, right? I'm just going to stick with the standard algorithm. So 6 times 7 is 42, 6 times 5 is 30, plus 4 is 34, 6 times 8 is 48, plus 3 is 51. Put a 0 placeholder. Moving on to my 3. 3 times 7 is 21. 3 times 5 is 15, plus 2 is 17. 3 times 8 is 24, plus 1 is 25. Put in 2 zeros this time. 2 times 7 is 14, regroup the 1. 2 times 5 is 10, plus 1 is 11. 2 times 8 is 16, plus 1 is 17. And then I'm going to add all this up. 2, 5, 2, regroup a 1, 2, regroup a 1, 0, regroup a 1, and 2. So I'm getting 202,252, right? But we didn't put any decimals in this, right? So I don't know where the decimal is. And this is really a nice method because it kind of reasons through it. If it was several months after you've learned this and you had to go back to it and you don't remember what the rule was for using decimals in the standard algorithm, you could just kind of reason your way through it with this method. So, I don't know where the decimal is. Maybe the decimal goes after this too, right? Maybe the decimal goes between the 5 and the 2. Maybe the decimal goes between the 2 and the 5, right? So just kind of listing some possibilities here. When you do this in practice, I would not expect that you would list all these out. What I'm doing right now is I'm kind of showing you what's in my head, right? So this is kind of what I picture in my head in terms of where that decimal might be, right? And guys, technically this isn't even all the possibilities, because technically we could have more zeros, in front of or behind this. So maybe this is 202252 and then the decimal, right? Or maybe there's another 0 in front of this, right? So like there's an infinite number of possibilities, but this is definitely plenty, right? And so how do I know where that decimal should go? Well, I estimated this, right? So I estimated that this was roughly 86 times 2, which is 172. So I know my answer should be reasonably close to 172. So like if you look at like all of these are way too big, right? This is 2022 and some change, or 20,000 something and change, right? Some hundred thousands. These are all too big. Sometimes call this my Goldilocks problem, right? That chair is too big. This one's too small. This one's just right. So those are all really too big. They're way bigger than 172. And then if I look at all of these, 20 and some change, 2 and some change, a decimal less than 1, right? Because this is technically 0.2. Those are all too small. And so what I'm really doing is I'm just looking for which one of these is the closest to my estimate. And in this case, it would be this one, right? So this one is just right. Or in other words, closest to 172. And so that's how I decide my answer, right? So I would decide that my decimal should go in between those two twos simply based on the fact that that's closest to my estimate. So I'm going to show you one more like this just because they can get a little tricky sometimes. So I said what I usually do when I estimate is I usually just round it to the nearest whole number, right? So if I were to round this to the nearest whole number, technically that 4 would mean that I estimate this as 0, right? Because the closest number to that closest whole is 0. So this would be 0 times, and then this one would be 6. Now, that is not going to give me a great estimate, right? Because 0 times anything is just 0. And this is not really going to be 0, right? So what I would do in this case is I would probably estimate this a little differently. You could go ahead, you could maybe round that up. That wouldn't be a terrible thing to do. So it's close enough. You could round it up to 1. What I might go ahead and do here though, is I might actually say, well, 0.5 is pretty easy to do, right? I usually don't round to a decimal, but if it's easy to compute in my head, then it makes a good estimate. So I know 0.5 or 5/10 is really 1/2, right? And half of 6 was 3, right? So that would probably be the best estimate to use here instead of 0, because 0 is not going to give you a very good estimate. And then what I'm going to do is I'm going to multiply these two numbers together as if the decimals aren't there. So I don't even need to write the 0 in front of the 48. I'm just going to think of that as 48. I'm going to think of this as 62, and I'm going to multiply those two together. So 2 times 8 is 16, regroup my 1. 2 times 4 is 8 plus 1 is 9. I'm going to write a 0 placeholder to move on to my 6. So 6 times 8 is 48. And 6 times 4 is 24 plus 4 is 28. And then I'm going to add all this up. So I'm getting 2976. My answer could be 2,976, or it could be 297 and 6/10, or it could be 29 and 76 hundredths, or 2 and 976 thousandths, or maybe the decimals in front of all that. So again, you don't have to write these, you don't have to show those, but this is what I'm seeing in my head, and I'm saying, oh, all of these way too big, right? My estimate's 3, right? So my answer should be reasonably close to 3. This one's way too small because it's smaller than 1. This one is just right. It's the closest to my estimate. So my answer here is going to be 2 and 976 thousandths.